In cryptography, a pseudorandom function family, abbreviated PRF, is a collection of efficiently computable functions which emulate a random oracle in the following way. No efficient algorithm can distinguish between a function chosen randomly from the PRF family and a random oracle. Pseudorandom functions are vital tools in the construction of cryptographic primitives, especially secure encryption schemes. Pseudorandom functions are not to be confused with pseudorandom generators. The guarantee of a PRG is that a single output appears random if the input was chosen at random. On the other hand, the guarantee of a PRF is that all its outputs appear random, regardless of how the corresponding inputs were chosen, as long as the function was drawn at random from the PRF family. A pseudorandom function family can be constructed from any pseudorandom generator, using, for example, the GGM construction given by Goldreich, Goldwasser, and Makala. Motivations from random functions. A PRF is an efficient deterministic function that maps two distinct sets and looks like a truly random function. Essentially, a truly random function would just be composed of a lookup table filled with uniformly distributed random entries. However, in practice, a PRF is given an input string in the domain and a hidden random seed, and runs multiple times with the same input string and seed, always returning the same value. Nonetheless, given an arbitrary input string, the output looks random if the seed is taken from a uniform distribution. A PRF is considered to be good if its behavior is indistinguishable from a truly random function. Therefore, given an output from either the truly random function or a PRF, there should be no efficient method to correctly determine whether the output was produced by the truly random function or the PRF. Formal definition. A family of functions, Fs 0, 1, lambda 0, 1, lambda, where S 0, 1, asterisk, and lambda, is pseudorandom if the following conditions are satisfied. Given any S and X such that X equals lambda, there always exists a polynomial time algorithm to compute Fs. Let Fn be the distribution of functions Fs where S is uniformly distributed over 0, 1, n, and let Rfn denote the uniform distribution over the set of all functions from 0, 1, n to 0, 1, n. Then we require Fn and Rfn are computationally indistinguishable, where n is the security parameter. Oblivious pseudorandom functions. In an oblivious pseudorandom function, information is concealed from two parties that are involved in a PRF. That is, if Alice gives the input for a pseudorandom function to Bob, and Bob computes a PRF and gives the output to Alice, Bob is not able to see either the input or the output, and Alice is not able to see the secret key Bob uses with the pseudorandom function. This enables transactions of sensitive cryptographic information to be secure even between entrusted parties. Applications. Dynamic hashing. Even if the adversary can change the key distribution depending on the values the hashing function has assigned to the previous keys, still he cannot force collisions. Constructing deterministic, memoryless authentication schemes which are provably secure against chosen message attack. Distributing unforgeable ID numbers which can be locally verified by stations which contain only a small amount of storage. Constructing identity friend or foe systems.